Welcome to Sleepy Nature Facts. The day is done. Whatever it asked of you, it has finished asking. There is nothing left to solve tonight, nothing left to decide, and nowhere else you need to be. So let your shoulders come down, away from your ears, and let the room go quiet around you. I want to tell you something before we begin. And I want to tell it to you plainly, because it is the only thing in the next 2.5 hours that I would like you to hold on to. Life has existed on this planet for something close to 3.5 billion years. And for the first 3 billion of them, nothing that was alive could travel anywhere. Nothing walked, nothing swam, nothing crawled or drifted with intention, or turned toward anything. 3 billion years of stillness. That number is difficult to hold in the mind, so let me set it down beside something smaller. Imagine that all of life's history were a single night's sleep. You lie down at 10 in the evening, and you wake at 6 in the morning. 8 hours for 3.5 billion years. The first traces of life appear almost immediately, within the first few minutes after the light goes out. And then, nothing much happens. Hour after hour. The night goes on. Midnight passes. 1 o'clock. 2. 3. The first creature to move under its own power, to decide, in some small way, to be somewhere else, does not arrive until roughly 20 minutes past 5 in the morning. Everything you have ever seen alive, every animal, every insect, every green leaf turning toward the sun, belongs to the last 40 minutes before waking. We are going back into the long part of the night. So let me place you somewhere. The shoreline is warm, warmer than any shore you have stood on. The water reaches your ankles, and it is the temperature of a bath that has been sitting a little too long, comfortable and slightly heavier than you expect. There is no wind, not a stillness between gusts, but a stillness that simply goes on, hour after hour, unbroken. The sky above you is not blue. It has no oxygen in it to scatter the light the way our sky does. So it hangs somewhere between pale orange and a soft, muted grey, hazier than you are used to. The colour of a distant morning seen through smoke that never clears. The sun is up there. It is dimmer than the sun you know, younger, and still finding its strength. And the moon is closer, much closer. Close enough that it fills a noticeable part of the sky, and it moves visibly through the night, faster than ours does, pulling tides that reach further up this beach than any tide you have watched. Now listen, because the most unusual thing about this place is not what you can see, it is what you can hear. There is water arriving at the shore and drawing back and arriving again. A soft, rhythmic breathing of the tide against wet stone. And there is nothing else. No bird song, because there are no birds. There will not be birds for another 3 billion years. No insects in the grass, because there are no insects. And there is no grass. No leaves moving, no creaking branches, no small sounds in the undergrowth, because there is no undergrowth. And nothing at all to make a small sound. Not one living thing on this entire planet is capable of producing a noise. The only sounds on Earth are the sounds of water and stone. Sit with that for a moment, an entire world. And the sea talking quietly to the rocks, and that is the whole of it. And the land behind you is bare, truly bare, not empty in the way a desert is empty. Because a desert has sand shaped by wind and hardy things clinging on at the edges. This is bare in a way that has no modern comparison. Dark volcanic rock, still relatively fresh. Loose grit, long slopes of stone running back from the water, and nothing growing on any of it. No soil. That is worth pausing on, I think, because soil feels so ordinary. It is simply there under everything. But soil is made. It is made by living things breaking rock apart and dying into it, and holding moisture in the spaces they leave behind. None of that has happened yet. So there is no soil anywhere on Earth, only stone, and the dust that stone becomes when it is worn down by rain. The rain here is warm, and it falls on rock that has never held a root. Now, I don't want you to think of this world as an empty one. It isn't. Life is here. It is simply not where you would look for it. If you were to kneel down in that warm, shallow water and hold your hand just beneath the surface, the water moving between your fingers would be full of living things. Millions of them in a single mouthful. They are single cells, each one smaller than anything your eye could resolve. Simple, soft, and complete in itself. And every single one of them is at the mercy of the water it happens to be in. This is the thing I keep returning to, and it is the quiet heart of this whole story. A cell in that water cannot go anywhere. It can drift if the water drifts. It can settle if the water goes still. But it cannot decide. It cannot turn toward warmth or away from it. It cannot follow a current to a better place, because it has no way to know that a better place exists, and no way to reach it if it did. It has no eyes. Nothing on Earth has eyes. It has no limbs, no fins, no thread of muscle, no nerve to carry the idea of moving from one part of the body to another. There is no from here to there. There is only here. And whatever here happens to bring. I find something restful in that, honestly. Not sad, restful. Because everything that troubles a living thing capable of movement simply does not apply here. There is no distance to cover, nothing to reach, no arrival that is being delayed, and no departure being put off. Nothing here is late, nothing here is going anywhere at all. And it has been that way for a length of time that the mind is not really built to contain. Let me try to give you the shape of it anyway. The first animal that could travel appears around 560 million years ago. Everything you would recognize as a living world happens after that. Every forest, every ocean full of fish, every ice age, every footprint in every layer of rock, anywhere on Earth. That is the last sixth of life's history. The other 5/6, the great bulk of it, the deep middle of the night, is the part we are standing in now. Warm, shallow water, hazy sky, bare stone, and an ocean full of small, soft, patient things, going wherever the water takes them. Visual. Return to the opening shot. Static wide, shallow water under low light, flat surface. Hold, we have a very long way to go. We will watch chemistry become something that can copy itself slowly on the floor of a dark ocean. We will watch domes of stone rise from the shallows, built by things without hands or plans or eyes, one thin layer at a time, at less than 0.5 millimetre a year. We will watch the sky change color over the course of 200 million years, as fine red particles settle endlessly through still water and gather on the seabed in stripes you can still put your hand on today. And then we will spend a long while in a stretch of time where almost nothing changes at all. 1,000 million years of the same warm sea, the same quiet shore, the same soft light. I'll be honest with you, that section is not eventful. That is rather the point. And at the very end, in the last minutes of this long night, something will move, not far, a few centimeters across soft sediment, and it will leave a groove behind it, which is still there, pressed into rock, and which is the oldest evidence we have of any living thing deciding to be somewhere else. We'll get to it eventually. There is no rush. But for now, Stay here on the warm shore. Let the water come up around your ankles and go back and come again. Let the sky stay hazy and low. Let the stone stay bare. Nothing is coming, nothing is going. There is only this, water and rock and warm, still air, and the deep, unbroken quiet of a world that has not yet learned to move.
Stay where you are for a moment longer. The warm shore, the shallow water at your ankles, the hazy sky with its oversized moon. Nothing has changed and nothing is going to, but I'd like to take you somewhere else now. And we're going to go down, away from the shoreline, away from the light, out past the shallows, where the sea slopes gently away beneath you, and then more steeply, and then the floor drops out of sight altogether. Let yourself sink slowly. The water grows cooler as you go, then cold, and the light thins from grey to a deep, soft blue, and then to something that isn't quite blue anymore. 200 meters, 500, 1,000. The last of the light is gone now. Really gone, not dim. And the water around you is black and heavy and perfectly still. You are somewhere on the floor of a young ocean, roughly 4 billion years ago. And here, in the complete darkness, something is happening. It is happening very slowly. It has been happening for a long time already, and it will go on happening long after any of this is settled. Ahead of you, there is warmth in the water. You would feel it before you saw anything. A gentle unevenness in the cold, a thread of something warmer drifting past. And then shapes. They rise from the seafloor like pale towers. Some are a few meters tall. Some are considerably taller, leaning, branching, growing into one another, forming clusters and thickets of stone. They are not smooth. Their surfaces are rough and mineral and layered, built up in flanges and shelves and delicate cauliflower forms, the way limescale builds in an old kettle, or the way a cave grows its stone from the ceiling down. And they are warm, not hot. Warm, perhaps the temperature of a comfortable bath, perhaps a little more, where they meet the cold water around them. These are alkaline hydrothermal vents, and they are, to my mind, the most quietly remarkable structures ever to have stood on this planet. Here is what is happening inside them. Seawater seeps down into cracks in the young ocean crust. It works its way through the rock below, slowly, over years, reacting with minerals it meets down there, and it comes back up changed. Warmer, chemically altered, carrying dissolved minerals with it. When that altered water meets the cold ocean again at the seafloor, those minerals come out of solution and settle and build. Grain by grain, layer by layer, the chimney raises itself. A single one of these vent fields can go on doing this for tens of thousands of years. Not in bursts, not in episodes, continuously. The same warm water threading up through the same porous stone, night after night, if there were nights down here, for 400 human lifetimes, and then 400 more. And here is the part that matters. These chimneys are not solid. Cut one open, and you find that the interior is a foam of tiny compartments. Thousands upon thousands of small chambers, each one perhaps 1/100th of a millimetre across, separated by fine mineral walls, and all of them connected to one another by narrow pores. Warm water moves through that honeycomb continuously, unhurried, finding its way from chamber to chamber. It is, in every meaningful sense, a natural apparatus. Millions of small, warm rooms, thin walls between them, a steady, gentle flow of chemistry passing through, and on one side of every wall, the water rising from below, rich in hydrogen. On the other side, the ocean water carrying dissolved carbon. Two different chemistries, held apart by a membrane of mineral for tens of thousands of years, quietly leaking into one another. Something is going to come out of that. Not tonight, not this century, but something will. Let me stay with the stone a little longer, because the stone is doing more of the work here than you might expect. We tend to imagine the beginning of life as something that happened in water, a warm pool, a rich soup, molecules swimming about and eventually bumping into the right arrangement. But water is difficult. Water dilutes things. It carries them apart. Two molecules that might have joined usefully will more often simply drift away from one another and never meet again. What chemistry needs, what it has always needed, is a surface, somewhere to hold still. And the young Earth had two beautiful ones. The first is clay. Clay is not a simple mud. Look closely enough and clay minerals are made of sheets, flat, layered plates, stacked one upon another like pages, with narrow spaces between them. Those surfaces carry a faint electrical charge, and molecules drifting past will settle onto them and stay, held in place, lined up in rows, neighbors, suddenly, held close together in order for as long as the clay holds them. Something that would essentially never happen in open water becomes ordinary on a sheet of clay. The second is iron and sulfur. Down at the vents, where the warm mineral water meets the cold ocean, iron and sulfur come together and settle out as fine dark crystals, iron sulfide, lining the walls of those small chambers. These crystals are not inert. They pass electrons back and forth with a kind of ease. They lower the effort required for certain reactions to happen at all. They are, functionally, catalysts. And what is interesting, genuinely interesting, and one of the reasons this idea is taken seriously, is that clusters of iron and sulfur atoms, arranged in almost exactly this pattern, are still sitting at the center of some of the oldest and most fundamental proteins in your own body, right now, in your cells. As you lie there listening, little pieces of mineral chemistry, carried forward, unchanged in their essentials, for 4 billion years. So this is the workbench, warm porous stone, millions of small chambers, clay sheets holding molecules in rows, iron and sulfur lowering the cost of every reaction, and a steady, gentle current of chemistry passing through it all for tens of thousands of years without pause. Now, I want to be careful here, because it would be easy to make what follows sound like an event. It was not an event. There is no moment when chemistry became life. There is no first cell, no first spark, no threshold that something crossed on a particular afternoon. What there is instead is a very long gradient. Chemistry that is slightly more organized than the chemistry beside it. And then chemistry that is a little more organized than that. The line we draw between not alive and alive is a line we drew afterwards, for our own convenience, looking backwards across an enormous distance. At the time, nothing crossed anything. Still, somewhere in that gradient, something remarkable happens. A molecule forms that can copy itself. It is not a creature. It has no body, no boundary, no intent. It is a chain of simpler units, a string of chemical beads, with a shape that happens to make a certain thing possible. When the right loose units drift past, they settle against it in a particular order determined by the chain itself. And when enough of them have settled, there are two chains where there was one. That's all. There is no purpose in it, nothing is trying. It is simply a shape that, in the presence of the right ingredients, produces more of that shape. And now I'd like to tell you about the part that I think is the loveliest idea in all of biology. The copying is imperfect. It has to be. A perfect copier would produce nothing but identical chains forever. The ocean would fill with the same molecule, endlessly repeated, and that would be the end of the story. But the copying is sloppy. Now and then a unit settles in the wrong position. Now and then one is left out. Now and then the chain is a little longer, or a little shorter, or bent slightly differently than the one it came from. And most of those small errors make no difference at all. The chain copies a bit worse, or a bit less reliably, and it fades from the population. But occasionally, very occasionally, an error makes a chain that copies slightly better, and that one leaves more descendants. That is it. That is the entire engine. Imperfect copying and time. There is nothing more to the mechanism than that. No design, no direction, no goal being worked towards. Just chains that copying imperfectly, in warm water, in the dark, on the surface of stone. And that single arrangement, that small, mindless, patient loop, is what eventually produces the redwood and the humpback whale and the eye you are currently resting behind closed lids. But I want you to hold on to the time scale here, because we are not talking about a process with any urgency in it. Think about how long a single useful step might take. A particular arrangement of molecules forms in one of those small worms. It holds together for a while, and then it comes apart, as most things do. Somewhere else in the honeycomb, the same thing happens and comes apart. And again, millions of chambers, millions of attempts, nearly all of them going nowhere. A vent field runs for 20,000 years, and then the flow shifts, and the chimneys go cold and quiet, and everything that had been slowly assembling there stops. Elsewhere on the seafloor, another field is already warming, and the whole patient business begins again. The best estimates we have suggest that the Earth formed around 4.5 billion years ago, and that the oldest reasonably confident instances of life appear somewhere around 3.5. Whatever happened in between happened across several hundred million years. Several hundred million years of warm water moving through porous stone in complete darkness at the bottom of an ocean nobody was looking at. That is not a beginning that anyone witnessed. It is not a beginning that would have looked like anything at all, even if someone had been there to watch. You could have sat beside one of those chimneys for 1,000 years, 1,000 full years of unbroken attention, and seen nothing happen whatsoever. Warm water, cold water, pale stone, dark crystals, and the slow, unremarkable accumulation of arrangements that were very slightly better at persisting than the arrangements around them. Let the water hold you here for a while. It is warm where you are, and cold a little further out, and the boundary between them moves gently the way warm air moves above a road. Above you there is a mile of black water, and above that a hazy sky and an oversized moon, and a bare stone shore where nothing grows. And below you, in the fine pores of a warm mineral tower, chemistry is very slowly learning to repeat itself, not going anywhere, not becoming anything yet, just continuing, layer by layer, chamber by chamber, in the dark and in no particular hurry at all.
Come back up from the vents, up through the cold black water, slowly, the way you came down. The cold thins, grey gathers above you, and then the shallows, and then the surface, and then the shore, the warm water at your ankles. the bare stone behind you, and now look up, because there is something in this sky that I have mentioned only in passing, and it deserves an evening of its own. The moon is too close. It is bigger than any moon you have looked at. Not a coin held at arm's length, a face, broad and low and detailed, taking up a noticeable portion of the sky, and it is moving, not quickly, but visibly, if you were patient, drifting across the sky at a rate you could measure against the edge of a rock in an hour or two. It is younger than the moon you know. Its surface is less battered, less grey. Some of its old volcanic plains may still be faintly warm, and it is far nearer to you than the moon has ever been in the whole of human history. Let me tell you how it got there, because it is a gentler story than you might expect. Early in the life of this solar system, when the Earth was very young, only a few tens of millions of years old, it was not alone in its orbit. There was another body sharing that path around the Sun, smaller, roughly the size of Mars, and over a long stretch of time, their orbits drew together. They met, not as a collision in any sense you would picture. At the scale of planets, coming together is a slow business, a matter of hours, and mostly of the two bodies merging into one another under their own weight. Most of the smaller body joined the Earth and stayed. Its core settled inward and became part of ours, and a great deal of material from both was lifted away. That material did not disperse. It settled into a ring around the young Earth, a broad disk of rock and dust turning, and rings do not stay rings. Particles in a ring meet one another gently, again and again, and stick. Small clumps become larger clumps. Larger clumps sweep up what is near them, over something in the order of century, perhaps rather less. The ring gathered itself into a single body, the moon, and when it formed it was close, very close. The best estimates put it somewhere around a tenth of its present distance. Perhaps 20 or 30,000 kilometers against the 380,000 of tonight, which would have made it appear something like 10 times wider in the sky than the moon you know. I would like you to try to hold that image, not a lamp in the distance, a world, filling a substantial part of the sky, low over the water, close enough to see the shape of its planes without any instrument at all. And nothing on Earth ever looked at it. There would not be an eye on this planet for another 3 billion years. The most extraordinary sky this world has ever had, hung over an ocean of single cells, and was never once seen. Now, a moon that close does something to the water beneath it. The tide, you know, is a modest thing, a meter or two on most coasts, 6 or 7 where the geography concentrates it. The tide on this shore is not modest. It is many times larger. The water withdraws across the flats until it is a long way out, and then it returns, and it comes far further up the land than any tide you have watched. But the size is not the part that interests me most. It is the speed, because the Earth is turning faster than you are used to, much faster. Early on, very early, not long after the moon formed, a day on this planet may have lasted only 5 or 6 hours. Sunrise to sunrise, 6 hours. By the time we are standing here, in the shallow seas of the Precambrian, it has slowed somewhat. A day is perhaps 18 hours, perhaps 21, still short, still noticeably, bodily short, which means the tides come more often. The water rises and falls and rises again, over and over, at a pace that would feel restless to us, and which is, to this world, simply the ordinary rhythm of things. I said earlier that the only sound on this planet is water on stone. This is where most of that sound comes from. Not waves in the way we picture them, not surf. A long, broad, unhurried flooding of shallow ground. Water arriving over flats and low rock, spreading, filling every hollow, and then withdrawing again, draining through channels it has worn for itself, leaving wet stone shining behind it, over and over, every 18 hours or so, for 1 billion years. Now here is the part I find most difficult to let go of. We can read this. We can go to certain rocks, laid down in tidal flats hundreds of millions of years ago, and we can count the tides directly. They are called tidal rhythmites, fine layers of sediment laid down in a tidal setting, where each layer records a single flooding of the flats. And because tides are not all equal, because they run through a cycle of stronger and weaker over the course of a month, following the moon. Those layers vary in thickness in a pattern. Thick, then thinner still, then thickening again. Which means that if you take a piece of that rock and you count the fine bands between one thick layer and the next, you are counting the days in an ancient month. People have done it. In rock from around 600 million years ago, the count comes out at somewhere near 400 days is a year, rather than 365. The year was the same length. The days were shorter, so more of them fit inside it. There is a stone somewhere with the tides of a Tuesday in the Precambrian written into it, not metaphorically. Actually, a band of sediment laid down by one particular flooding of one particular shore on one particular day 600 million years ago, and nothing was there to see the water come in. Now let me tell you where all of this is going, because the arrangement you are standing in tonight is not stable. The tides are doing work. Every time that water is dragged across a shallow seabed, there is friction. Water against sediment, water against rock, a small resistance everywhere all the time. And friction takes energy out of a spinning thing, so the Earth is slowing very gently, about 1 8/10 milliseconds added to the length of a day per century. That is nothing. It is invisible. No instrument on this planet could have measured it in any single human lifetime. But it does not stop, and the energy has to go somewhere. It goes into the moon's orbit, and an orbit-given energy widens. So the moon is moving away 3.8 centimeters a year, about the rate a fingernail grows. 3.8 centimeters a year is a very small thing, and 1 billion years is a very long time. So it adds up. The enormous moon over your head tonight will shrink over the course of the story we are telling, from something that fills the sky to something rather more like the one you know. And the days will stretch. 6 hours becomes 18. 18 becomes 21. 21 eventually becomes 24. And the tides will settle into the gentle twice-daily rhythm we take entirely for granted. None of that happens at any particular moment. There is no evening when the moon looks smaller than it did. No morning when the day feels longer. Only a fraction further out this year than last. A fraction longer than yesterday. Repeated without interruption for 4 billion years. I want to leave you with one more thought about all this, and then we can go back down to the water. The moon is still going. Right now. Tonight. Wherever you are. 3.8 centimeters further out this year than last year. The day you have just finished was a fraction of a millisecond longer than the day your parents were born into. It is the slowest departure imaginable, and it has been underway, without pause, since before there was anything alive on this planet to feel the tide it pulls. So stay on the shore a while longer. The water is warm at your ankles. It is coming in. And it will come further than you expect, and it will do it more quickly than you are used to, because the moon above you is far too close, and the world beneath you is turning far too fast. And in a few hours, it will draw back, and the flats will be wet stone shining under an enormous low moon, and then it will begin again. 18 hours, then 18 more. Nothing on the shore is troubled by it. Nothing on the shore is anything at all yet. Only water and stone and a rhythm that has been keeping time since before there was anything to keep it for.
Let us come back up, slowly, the way you came down, away from the warm mineral towers, away from the honeycomb of small chambers, up through a mile of cold black water. The cold thins. Somewhere above you, a faint suggestion of grey begins to gather, and then it becomes blue, and then it becomes something warmer than blue. 600 meters, 300. The water grows gentler around you, and then you break into the shallows, and the light is soft and hazy, and the seabed is close enough beneath you to touch. We have moved forward in time, as well as upward. We are now somewhere around 2.5 billion years ago. and we are standing in a lagoon. The water here is warm again and shallow, knee-deep for a long way out, waist-deep further, and rarely much more than that. It is very salty, saltier than the sea, you know. The tides here reach far up the flats and then draw back, and the sun works on what remains. And over long stretches of time, the water has become heavy with it. And it is quiet, the same quiet you left up at the shoreline, water on stone and nothing else. But look down, because the floor of this lagoon is not sand. Rising from the shallow bed, there are shapes, domes, columns, low mounds and broad flattened cushions. Some are the size of a loaf of bread. Some come up to your knee. Some, further out, are as tall as you are and broader across than your arms could reach. They stand in fields, hundreds of them, thousands, spreading out through the shallow water in every direction until the haze takes them. These are stromatolites, and they are, in the most literal sense, buildings. Here is how one is made. On the surface of the seabed, there is a film. It is thin, thinner than a sheet of paper, and it is made of living cells, cyanobacteria, mostly, along with a great many others. Billions of them packed together into a layer, spread flat across the sediment. Each cell is doing something very simple. It is taking in light and water and carbon, and it is producing sugar for itself. That is nearly the whole of its life. And as a byproduct, as an incidental leftover of that process, the cells excrete a fine sticky substance, a kind of mucus spread across the surface of the mat. The mat is sticky. That is the entire mechanism, nothing more elaborate than that. Now the tide comes in. The water arriving over the flats carries fine sediment with it, grains of carbonate, particles of silt, dust that has blown out from the bare land and settled on the sea. And when that water passes over the mat, some of those grains stick, just a scattering, a thin dusting across the living surface. The tide goes out again, and the mat now finds itself with a fine layer of sediment lying over the top of it, blocking the light. The cells beneath cannot photosynthesize through it, so they move, not far, a fraction of a millimetre, not by walking or swimming or anything we would call travel. They glide, on their own secretions, upward through the grains, reaching for the light, and they arrive at the surface again and spread out flat and reform the mat on top of the sediment that has just settled, and then the tide comes in again. That is it. Sediment settles. The mat grows up through it. Sediment settles again. A layer of grains, then a layer of life, then grains, then life, over and over and over, with the tides, year after year, until the layers become a stack, and the stack becomes a mound, and the mound becomes a dome standing in the shallow water. Grain by grain. I'd like you to sit with the rate at which this happens. A stromatolite grows by something in the order of 1/3 of a millimetre in a year. That is not a figure that means much said aloud. So let me put it another way. A stromatolite the height of your knee, a modest one you would step around without much thought, has taken about 2,000 years to reach that height. 2,000 years. It began before the Roman Empire. It has been adding a fraction of a millimetre every year since, through every century of recorded human history, and it is now roughly the height of your knee. The larger ones, the ones out in the deeper water, the ones you could not put your arms around, those have been growing since before the pyramids. Some of the fossil examples we find in ancient rock were still growing after 10,000 years, 20,000, unbroken. And here is what I find most affecting about all of this. Every one of these structures was built by things that could not see them. There is no eye anywhere in this lagoon, not one in the whole of this ocean, on the whole of this planet. Nothing here has ever perceived a shape. The cells that built these domes have no way of knowing that a dome is what they are making. They have no sense of up except as a direction where light is stronger. They have no sense of the structure beneath them, no awareness that they are the top layer of something 2,000 years in the making. Each cell simply glides towards light and settles and gets on with the day. There is no plan. Nobody chose the shape. Nobody is measuring anything or correcting anything or intending anything at all, and yet the shapes are consistent. Domes here where the water moves a little, columns there where it moves more, flat, broad mats where the water is still. The architecture emerges from the physics, from how water flows, and how grains settle, and how light falls. Architecture without an architect. Buildings raised by builders who have no hands, no tools, no plans, no sight, and no idea whatsoever that they are building. Now widen out for me, because a lagoon like this one is not unusual at this point in Earth's history. It is ordinary. For well over 1 billion years, this was simply what shallow water looked like. Every coastline, every lagoon and tidal flat and sheltered bay on every landmass. Fields of these domes standing in warm, salty water, adding 1/3 of a millimetre each year. There were, by some estimates, more stromatolites on Earth then than there have ever been reefs since. Entire coastlines, thousands of kilometres of them, built out of patient microbial stone. And in all of it, nothing moved. The water moved. The tides came and went. Sediment drifted and settled, but nothing living crossed the floor of that lagoon. Nothing swam between the columns. Nothing grazed on the mats, because nothing existed that could graze. Nothing rested in the shadow of a dome or scraped at its surface or knocked a fragment loose. The structures were entirely undisturbed for 1 billion years by anything except weather. And now I want to tell you the part of this that I think will stay with you. They are still there, on the western coast of Australia, at the far end of a long, shallow inlet. There is a place called Hamelin Pool. It sits behind a bar of seagrass and sediment that has built up across the mouth of the bay over thousands of years. That bar restricts the flow of water in and out, and the sun works on what is trapped behind it, and the result is water roughly twice as salty as the open ocean. Almost nothing can live in it, nothing that grazes, nothing that burrows, nothing that would disturb a mat on the seabed. And so, in Hamelin Pool, the mats are undisturbed, and they do what they have always done. There are stromatolites growing there right now, dark domes and columns standing in clear, still, very salty water. Some of them are over 3,000 years old. The mats on their surfaces are laying down a fraction of a millimetre this year, exactly as they did last year. You can walk out on a boardwalk above them. I find that genuinely extraordinary, and I mean that quietly, because it means the oldest form of life we can point to. The one that filled the shallow seas of a world with no oxygen, no plants, no animals, no soil, and no sound did not end. It simply retreated. It withdrew into a handful of places too salty, or too hot, or too strange for anything else to bother it, and there it carried on, doing precisely the same thing, at precisely the same rate. The lagoon you are standing in tonight is 2.5 billion years old, And there is a bay in Western Australia where the water is still warm and still shallow and still much too salty. And the domes are still rising 1/3 of a millimetre a year under a sky that has changed completely beside a continent that has moved halfway around the world. Let the light go soft here. The tide in your lagoon is drawing back. The domes stand a little higher out of the water than they did. Their wet surfaces dark and faintly glistening. The haze is settling. The oversized moon is low. And the mats on every one of those thousands of structures are gliding imperceptibly upward through the day's fine layer of sediment towards a light that is going anyway. They will be a fraction of a millimetre taller by next year. They are not waiting for anything. They are not going anywhere. They are simply continuing, grain by grain, layer by layer, in the warm and the shallow and the quiet. Stay in the lagoon. We are not going anywhere for this chapter. Not really. The domes are still around you. The water is still warm and shallow and salty. The mats are still gliding upward through their fine layer of sediment, exactly as they were. But something is changing. It is changing so slowly that no observer could ever have noticed it, and it will take longer to happen than the entire history of animals. Let me start with something small. Every one of those cells in every one of those mats is taking in light and water and carbon and making sugar. That is its whole occupation. That is what it does with the day. And when it does that, something is left over. The cell splits water apart to get what it needs from it. And water, once you have taken the hydrogen away, leaves oxygen behind. The cell has no use for it, so it lets it go. That is all oxygen is at this point in Earth's history. A leftover, an incidental exhalation from something that was doing something else entirely. Now multiply that. Billions of cells in every square metre of mat, thousands of square kilometres of mat along every shallow coastline on Earth. All of them letting go of the same leftover every day for hundreds of millions of years. And for a very long time, none of it goes anywhere. This is the part that surprises people, I think. The oxygen does not simply gather in the sky. Not at first. Not for an extraordinarily long time. Because the young ocean is full of iron. The seawater of this world is different from the seawater you know. Volcanic activity on the seafloor has been feeding dissolved iron into the oceans for 1 billion years, and with no oxygen anywhere to react with it. It has simply stayed there, dissolved, invisible, held in the water like sugar in tea. The oceans of the early Earth are faintly green because of it, and iron and oxygen have a particular fondness for one another. So the oxygen that drifts away from those mats does not rise into the air. It meets iron in the water, and it joins with it, and the two of them together become something that will not stay dissolved. They become a fine reddish particle, and a fine particle in still water does only one thing. It sinks. I would like you to hold that image for a while, because it is the quiet center of this whole chapter. An ocean, warm at the top, cold below, and largely undisturbed, because there is nothing swimming in it, and no deep current system like the one we have now, and nothing at all to stir it. And through that stillness, particles are falling. Not a shower, not a fall you would notice if you were down there. Fine reddish grains, individually far too small to see, descending through the water column so slowly that a single one might take weeks to reach the bottom. They have been doing this for as long as there have been mats, and they will go on doing it for hundreds of millions of years more. Down on the seabed, they arrive, and they settle onto the sediment already there, and they add a thickness to it that could not be measured by any instrument in a single human lifetime. Now, the amount of iron in the water is not constant. It varies, with the seasons perhaps, with the pace of volcanic activity on the seafloor, with how much life is going on in the shallows in a given stretch of centuries. When there is more iron settling, the sediment that gathers is red. When there is less, what settles instead is the fine silica and carbonate that is always drifting down, and that sediment is paler, grey or cream or a soft tan, red, then pale, then red again. And because nothing is disturbing the seabed, because there are no burrowers, no currents to speak of, nothing to mix the layers together, each of those settlings stays exactly where it landed, perfectly separate. A thin band of red, a thin band of pale, a thin band of red. Some of those individual bands are less than a millimetre thick. Some of them, we think, represent a single year. Now let this run. Let it run for 200 million years, band after band after band, red and pale and red and pale, settling silently onto the floor of a still ocean in a world where nothing has eyes and nothing can travel. The layers stack. The stack compresses under its own weight. The sediment becomes stone. And what you end up with is a rock formation hundreds of meters thick, composed entirely of fine alternating stripes, every one of them laid down by particles drifting slowly down through undisturbed water. They are called banded iron formations, and they are among the most beautiful rocks on this planet. You can stand in front of one today in Western Australia, or in Michigan, or in South Africa, or in Brazil. A cliff face in flat, overcast light, hundreds of meters of stone above you, and it is striped, fine red and grey bands running horizontally as far up as you can see and as far along as the outcrop goes, thousands upon thousands of them, each one a settling. You could put your hand flat against that cliff, and the width of your palm would cover perhaps 1,000 years of quiet falling. There is something else about these rocks that I've always liked. That iron did not stay in the ground. Banded iron formations are, today, the source of the overwhelming majority of the iron ore that human beings mine, which means that essentially every steel object you have ever touched came from this. Bridges, railway lines, ships, the frame of a building, a kitchen knife, the reinforcing bars inside a concrete wall. All of it, originally, was iron dissolved in a green ocean 2.5 billion years ago that met the leftover breath of something too small to see, and settled through still water for a few weeks, and came to rest on a quiet seabed. An entire material civilization built out of very slow sediment. Eventually, and eventually here means after several 100 million years of this, the iron in the oceans begins to run low, not everywhere at once, not neatly, in some basins before others, but gradually there is less dissolved iron to take up the oxygen that keeps arriving. And so the oxygen begins, for the first time, to stay in the water, and then to leave it. It rises out of the shallows and into the air, very little of it, a trace, a fraction of 1% of what you are breathing now, but it is there, and it is accumulating, and it has nowhere else to go. And over tens of millions of years, the sky changes color. I would love to be able to tell you what that looked like. The truth is that we can only reason about it. The old sky was hazy, thick with a fine organic mist, orange or brownish, the light diffuse and softened, the sun a warm smudge rather than a disk. Oxygen would have thinned that haze away. And as it thinned, the air would have grown clearer, and light would have begun to scatter through it in the way it scatters through our own atmosphere. Somewhere in there, over a span of time longer than the entire age of mammals, the sky became blue. Not on any particular day. There was no morning when someone might have looked up and noticed. Just a little clearer this million years than the last. A little more light getting through. A slightly deeper tone at the top of the sky. And after long enough, the ordinary blue we take entirely for granted, which had never existed before, was simply there. The world also cools during this stretch. The old air had held its warmth well. As it changed, some of that warmth was lost, and the planet became a cooler place than it had been. In some periods, considerably cooler. There is good evidence for long stretches of ice reaching much further towards the equator than we are used to. And that ice sat there, not for a season, not for a century, for tens of millions of years at a time. Underneath it, in the dark, the mats carried on, fewer of them, slower, in the shallows that stayed open, and in warm places on the seafloor, and in whatever pockets of light and liquid water remained. 1/3 of a millimetre a year, wherever they could manage it. And when the ice eventually drew back, over hundreds of thousands of years, they spread out again into the shallows they had lost. None of this was quick. I want to be very clear about that, because it is easy to compress a story like this into something that sounds like it happened. The whole of it, from the first oxygen accumulating, through the settling of the iron, through the thinning of the haze and the cooling and the ice, takes something in the order of 400 million years. 400 million years. That is longer than the time between the first fish and this evening. Every animal that has ever existed, every forest that has ever grown, every mountain range currently standing, all of it fits inside a span shorter than the changing of the air. And through the entirety of that span, nothing on Earth was capable of going anywhere. So let the chapter settle here. The water around you is a little less green than it was. The sky above is a little less hazy. The domes are unchanged, still adding their fraction of a millimetre, still gliding upward through the day's fine dust. And a long way out, past the shallows, in the deep still water, where the light does not reach, particles are falling, fine, reddish, far too small to see, taking weeks to make the journey down, landing on a seabed that nothing has ever disturbed, building, one silent settling at a time, a cliff face that will still be standing 2.5 billion years from tonight. Nothing is hurrying. Nothing has ever hurried. There is only the water and the drifting and the slow, patient accumulation of a world. We have spent this whole evening in water, the vents and the lagoon and the shallow rock and the settling of the iron, and that is where the story of life is. For 3 billion years, it is entirely and only there. But there is another surface on this planet, and it has been sitting above the waterline the whole time, doing almost nothing, for longer than the ocean has held anything you would call a body. Let us turn around. Walk up from the shore with me. The wet stone gives way to dry stone within a few paces. The sound of the water fades behind you sooner than you expect. There is nothing to carry it, no trees to catch it, no ground soft enough to absorb it. The rock underfoot is dark, volcanic mostly, rough in places, worn smooth in others where water has run over it for a long time. And it goes on, up the slope and over the rise and down the other side, and on for hundreds of kilometers, for thousands. Bare rock. I want to be precise about what is missing here. because it is easy to picture a desert and think you have it. You do not have it. A desert has sand shaped into dunes by wind and stubborn things growing at the edges, and burrows and tracks and the remains of what lived there last season. There is nothing here, no plant of any kind, not a blade, not a stem, not a fleck of green anywhere on the surface of this planet. No animal, obviously. Nothing walks, and there is nothing that could. No tracks, no burrows, no droppings, no bones, no wood anywhere ever, no leaf that has ever fallen, and no soil. I keep coming back to the soil because I think it is the hardest absence to actually feel. Soil seems like a thing the world simply has. It is what is under the grass. It is what you dig into. It is the default state of the ground. It is not. Soil is manufactured. It is made by living things. Roots prizing rock apart. Threads of fungus working into cracks. Dead material falling and rotting and mixing with the mineral grains beneath it. And small creatures turning the whole arrangement over and over. Every one of those processes requires something alive to be up here. Nothing is up here. So there is no soil on the earth. Not a handful, not anywhere. There is stone, and there is what stone becomes when it is worn down. So let me tell you what does happen up here, because something does. It rains, and the rain on this world is warm, and it is frequent, and when it falls on stone that has never held a root. There is nothing to slow it, no canopy to break it into drops, no leaf litter to soften where it lands, no roots to hold anything in place beneath it. So the water simply arrives at the rock and runs, and it takes things with it. This is weathering, and for 3 billion years it is the entire story of the land. Water gets into cracks. When it is cold enough, it expands and widens them a fraction. When it is warm, it dissolves what it can and carries it away. The rain is faintly acidic, more so than ours in that carbon-rich air, so it works at the minerals steadily wherever it touches them. Rock breaks into blocks, blocks break into grit, grit breaks down further into fine clay, slowly, grain at a time, and all of it moves downhill because there is nothing whatsoever to hold it. Which brings me to something I find genuinely lovely, and which took me by surprise the first time I understood it. The rivers on this world are the wrong shape. A river, you know, has banks. It runs in a channel, a defined line across the landscape, sometimes deep, holding its course for long stretches. That shape exists because of plants. Roots bind sediment together. Vegetation on a bank holds it in place against the water. A river cuts down, and the sides hold, and you get a channel. Take the plants away, and nothing holds. So the rivers of the early earth do not cut channels. They spread. Wide, shallow, braided sheets of water, running in many shifting strands across broad plains of loose sediment, splitting and rejoining, moving sideways across the landscape from one season to the next, kilometers wide in places, ankle deep. You can see it in the rocks. The sandstones of this age are laid down in broad sheets rather than in narrow channel forms. The shape of ancient rivers is preserved in the shape of the stone they left behind. Every river on this planet, for 3 billion years, was a wide, shallow braid across bare ground. And then there is the wind. The wind here has nothing to push against. No trees to bend, no grass to move in it, no leaves to turn over. It moves over bare rock and loose grit, and it lifts the fine material, and it carries it. Dust storms on a world with no soil to hold anything down. Fine particles traveling long distances across bare continents and settling out over the sea. That dust matters, incidentally. It carries iron and other minerals out to the open ocean, where they feed the very cells we have been watching all evening. The mats in the lagoon are partly built from the slow disintegration of a landscape that nothing has ever grown on. Now listen, up here, because the sound is different from the shore. There is rain when it comes on rock, which is a harder and brighter sound than rain on ground, you know. There is running water in the shallow braids, which is a broad and low and constant sound rather than the chatter of a stream in a channel. There is wind over stone, and there is nothing else at all. No leaves, no insects, no birds, no creaking, no rustling, no small movement in the undergrowth, because there is no undergrowth and no small movement anywhere on the surface of this continent. Rain, water, wind, stone for 3 billion years. And the continents themselves are not still, though you would never know it standing here. They are moving, a few centimeters a year, about the rate the moon is receding, about the rate your fingernails grow, which over hundreds of millions of years is a great deal of movement. Ocean basins open, land masses drift apart and travel and arrive against one another and join. Supercontinents assemble, several of them over the span we are covering tonight, and then break apart again. Mountains rise where land meets land, and then the rain gets at them and the wind gets at them, and with no roots anywhere to hold their slopes together, they wear down more readily than mountains do now. Rise and wear away, rise and wear away. None of it witnessed, none of it recorded by anything except the rocks themselves. I would like to put one more thing in your mind before we go back down to the water. Think about a beach, you know. The sand on it came from somewhere. Every grain was once part of a rock, and was broken down, and was carried, and was sorted by water, and arrived there. For 3 billion years, every grain of sand on this planet came off a landscape where nothing had ever grown. There is no leaf matter in that sand, no fragment of wood, no shell, no bone, no trace of anything that had ever been alive. It is purely mineral, stone, worn down by weather, and nothing else. Clean in a way that no beach has been since. The land will not stay like this forever. Eventually, and it is a long way off from where we are standing, a long way past the end of this evening, something will come up out of the water and stay. Thin films of green on wet rock first, then small things clinging near streams, then roots and soil and everything that follows from soil. But that is much later. Tonight, the continents are bare from shore to shore, every one of them, all the way around this planet. Rock and grit and wide shallow water running over it, and dust lifting in a wind that has nothing to move. Let us go back down to the shore, down the slope, over the worn stone, toward the sound of the water. It gets louder as you come, the broad, unhurried flooding of the flats, arriving and spreading and drawing back. The tide is coming in. The moon is low and much too large. And behind you, all the way to the far coast of a continent nobody has ever crossed, there is bare rock in the dark, with rain falling on it, and nothing growing, and nothing moving, and nothing there at all to mind. We are going to stay in one place for this chapter. I want to tell you that at the start, so that you are not waiting for anything. There is nowhere we need to get to. There is nothing coming. We are simply going to stand in the shallow water for a while and let a very long time pass around us. We have arrived at a stretch of Earth's history that geologists have sometimes called the boring billion. That is a real term. People use it half affectionately, in papers and at conferences. It refers to a span of roughly 1,000 million years, from about 1.8 billion years ago to about 800 million years ago, in which, by the standards of everything before and everything since, remarkably little happened. The oxygen level does not rise much. It sits low and it stays low. The climate does not swing. There is no great ice and no great warmth. The temperature settles into something moderate and holds there. The chemistry of the ocean settles as well. Layered, quiet, stable, and life, which already exists, and which by now includes complex cells with all their internal machinery, does very little with any of it. 1,000 million years. I would like to use that phrasing rather than 1 billion, because billion is a word that slides past. 1,000 million is harder to let go of. I do not much care for the word boring applied here. I understand why it is used. From a certain distance, it is a stretch of the record with nothing to point at. But nothing is a strong word for a world of warm, shallow seas and drifting cells and stone rising a fraction of a millimetre a year. For 10,000 centuries, I would rather call it undisturbed. Let me show you what 1,000 million years of undisturbed looks like. We are going to visit this same lagoon 4 times. The first visit, 1.8 billion years ago. The water is warm and shallow and clear. It comes to your knee for a long way out and to your waist further on. The domes stand in it, a field of them, dark and rounded, spreading away until the haze takes them. The mats on their surfaces are gliding upward through the day's fine dust. Above the sky is a soft muted blue, still a little hazy, and the sun is a warm smudge behind the thinness of it. There is no wind at present. The tide will come in later, and it will lay down another dusting of sediment across every mat in the lagoon, and by the time it draws back, they will have risen through it. The only sound is water on stone. Let us leave that afternoon and come back later. The second visit, 1.5 billion years ago. 300 million years have passed. To give that its proper weight, 300 million years is longer than the entire age of dinosaurs, from first to last, with 100 million to spare. The water is warm and shallow and clear. It comes to your knee for a long way out and to your waist further on. The domes stand in it, a field of them, dark and rounded, spreading away until the haze takes them. The mats on their surfaces are gliding upward through the day's fine dust. The sky is a soft muted blue. The sun is a warm smudge behind it. There is no wind at present. The continents have moved out beyond the horizon, slowly, a few centimeters a year, about the rate your fingernails grow. Over 300 million years, that adds up to entire ocean basins opening and closing, and land masses arriving against one another and joining. There is a supercontinent assembling somewhere on this planet as you stand here. You cannot see any of it. It makes no difference to the lagoon. The only sound is water on stone. The third visit, 1.2 billion years ago. Another 300 million years. The water is warm and shallow. The domes stand in it. The mats are gliding upward through the day's fine dust. Out in the open ocean, the water is layered, warm and thin at the surface, cold and heavy below, and very little exchange between the two. The upper layer holds a small amount of oxygen. Beneath it, the deep water holds essentially none, and has not for a very long time. That boundary does not move much. It sits where it sits, for hundreds of millions of years, a quiet line through the middle of every ocean on Earth. Life is doing something in this period, though it is difficult to see. Complex cells, cells with a nucleus, with internal compartments, with all the elaborate architecture that yours have, are already here. They have been here for a while. They are drifting in the water and living within the mats and settling on surfaces. And they are, on the whole, not becoming anything in particular. The capability is present. The circumstances do not seem to call for it, so they carry on as single cells, competent and complete and going nowhere at all. The sky is a soft, muted blue. The only sound is water on stone. The fourth visit. 900 million years ago. The water is warm and shallow. The domes stand in it. The mats are gliding upward through the day's fine dust. 900 million years ago is closer to tonight than it is to the first visit we made in this chapter. I want to say that again, because it is difficult to hold. The distance between our first stop and our fourth is greater than the distance between our fourth stop and this evening. We have spent this chapter crossing a gap larger than everything that has happened since. And the lagoon has not changed. The supercontinent that was assembling has assembled and has begun to come apart again. The oxygen has risen very slightly and fallen very slightly and risen again. Some of the mats have new residents, algae, small and simple, tucked among the bacteria. That is the whole of the news. Now let me stay here with you for a while and simply describe the lagoon, because there is nothing else this chapter needs to do. The water at your ankles is warm. It is very slightly salty on the skin and heavier than fresh water, and it moves against you when the tide draws. The bed beneath your feet is fine sediment, pale, soft, giving a little underweight. The nearest dome is an arm's length away. Its surface is dark and faintly glistening and slightly textured, like wet leather or the skin on cooling milk. Under your hand it would be slick and firm and slightly yielding. It is warm from the day. Beneath that surface film there are layers, hundreds of them, then thousands, going down into the dome. Every one of them was once the top. Every one of them held the light for a season and then was covered and stayed. Further out, the domes get larger and further apart. The water between them is clear enough to see the bed for some distance, and then the haze of the light takes it, and the far ones are only shapes. Above, the sky, soft, muted, the sun a warm, indistinct disk, low. Behind you, the land, bare stone, running back and up. No soil yet. That is still hundreds of millions of years away. No green anywhere on it. Rain has worn it into channels, and dust blows off it and settles on the water. And in every direction, the quiet. Water on stone, nothing else. I said at the start of this chapter that we would stay in one place, and we have. 1,000 million years, 10,000 centuries of warm, shallow water and rising stone. Nothing was waiting. Nothing was building towards anything. There was no long preparation going on beneath the surface, no pressure gathering, no clock running down. It was simply a world that had found a way to be, and then went on being it, for a length of time that makes the whole of animal life look like an afternoon. And through the entirety of it, nothing on Earth could go anywhere. The cells in the water went where the water went. The mats went upward, a fraction of a millimetre toward the light. And that was the sum of all movement on this planet for 1,000 million years. Stay in the shallows. The water is warm. The domes are dark and still. The light is soft and low and going, and there is nowhere at all to be. something has changed. Not much, not quickly. But after the chapter we have just spent together, anything at all is worth mentioning. Let me take you into shallower water. Not the lagoon this time, somewhere a little further along the coast, where the bed is rock rather than sediment, and the water moves a little more. Knee-deep, clear, cool at the ankle. Look at the rock beneath the surface. There is something growing on it. It is small, perhaps 2 millimeters tall, about the thickness of a coin standing on edge. It is a thread, a fine filament, reddish, rising from the rock and swaying very slightly with the movement of the water. And it is attached. That is the thing to notice. It is not drifting past, it is not suspended. It has a base, a small holdfast, gripping the stone, and it is anchored there, and it will be anchored there for the whole of its life. This is Bangiomorpha, and it is about 1 billion years old. We know it well from rocks in Arctic Canada because it fossilized in remarkable detail, and it is one of the more significant small things ever preserved. Here is why. It is made of many cells, a chain of them, stacked end to end into a filament. But the cells are not all the same. The ones at the base are shaped differently from the ones above. The base cells make the holdfast, the grip, the anchor. The cells further up do the work of catching light. Different cells doing different jobs within a single organism. That is a body. Not much of one, but the idea is present. And it is present here about 1 billion years ago, in something 2 millimeters tall. And there is more. Bangiomorpha is the oldest organism we have found that appears to have reproduced sexually. 2 parents, cells that combine, offspring that are a mixture of both, rather than a copy of one, which means that 1 billion years ago, in shallow water, on a piece of bare rock, under a hazy sky, on a planet where nothing had eyes and nothing could travel, 2 threads of red algae exchanged material and produced something that had never existed before. That is the oldest such moment we can point to. Now let me widen this out, because Bangiomorpha is one example of something that was happening in many places. Cells had been dividing for 2.5 billion years by this point. 1 becomes 2. The 2 drift apart. Each goes on its own way into the water. That is the arrangement, and it works perfectly well. And it had gone on essentially unchanged for longer than everything since. But sometimes they did not drift apart. Sometimes the division was incomplete, or the outer wall stayed joined, or the sticky substance between them simply held. And you would have 2 cells attached, then 4, then 8, a short chain, a small clump, a flat sheet, a few cells across. That is not much. It happens by accident. It probably happened countless times over billions of years and came to nothing at all. But occasionally, staying attached was slightly better than not. A clump is harder to consume than a single cell. A chain reaches a little higher into slightly better light. A sheet anchored to rock stays in a good place rather than being carried somewhere worse. Nothing chose any of this. The clumps that held together left more clumps behind them. That is the entire explanation, and it is the same engine we met at the vents, running slowly in the shallows for hundreds of millions of years. So the shallow seas of this period begin to acquire a texture they did not have before. Let me simply describe it to you. There is no argument to follow in what comes next. It is a list, and it is meant to be one. On the rock in the shallow water, filaments, fine threads, reddish and greenish and brownish, rising 1 millimetre or 2 from the stone, anchored at the base, swaying together with the water all leaning one way, then the other, in unison. Beside them, sheets, flat, single-layered, spread across the rock like a stain, slightly slick to the touch, extending outward at their edges by a cell at a time. In slightly deeper water, tufts, small clustered growths, a few millimeters across, branching once or twice, anchored, bending in the current and returning. On the sediment, the mats, still there, still doing exactly what they have always done, still rising a fraction of a millimetre a year. Within the mats, a great many small things, bacteria in their billions, complex cells among them, threads winding between grains of sediment, cells that have settled and stayed. In the water above all of it, the drifters, single cells in their uncountable numbers, some round, some elongated, some with a fine thread trailing behind them, suspended, turning slowly with the water. And now I would like you to notice something about that entire list. Not one thing in it is going anywhere. The filaments are anchored, the sheets are attached, the tufts are gripping stone, the mats are fixed to the sediment they have made, and the drifters, the ones actually moving through the water, are not traveling, they are being carried. There is a real difference between those two things, and it is the difference this whole video rests on. Some of those single cells do have a thread, a fine whip at one end, which beats and which pushes them through the water. That is genuine self-generated motion, and it is very old, but it is motion of a particular kind. It is not navigation. There is no map and no destination, and nothing that could hold either. A cell with a whip might drift a little more towards light, or a little more towards warmth, by the simple chemistry of turning slightly when things improve. It cannot cross the lagoon. It cannot choose the far rock over the near one. In a lifetime, it might cover the width of a fingernail, and it will end wherever the water has left it. Everything in these shallows has a position. Nothing has a destination. Let me come back down to the rock and stay there for a while. I want to give you 1 square centimetre of it. Choose a patch about the size of a fingernail under a hand's depth of clear water. At the bottom, stone, slightly rough, slightly pitted, with the faintest film over all of it. That film is alive. It is bacteria, spread thin, a few cells deep, covering every part of the surface, including the inside of the pits. Rising from the film, 11 filaments. I am inventing that number, but it is a reasonable one. 11 fine threads across a fingernail's width, some reddish, some paler. They are between 1 and 3 millimeters tall. They are swaying. All of them lean together as the water pushes, and hold there a moment, and come back as it draws. A movement so gentle it would be easy to mistake for stillness. Between the filaments, sediment, fine pale grains settled into the low places, some of them moving a little when the water pulls, most of them staying. Among the grains, small threads winding, and cells wedged into the spaces, and the fine sticky substance holding it all in place. On one filament near the base, a slight thickening. That is where it has been growing. New cells added, one at a time, quietly, over weeks. On another, higher up, a slight paling. That is an older part, less active, doing less than it did. And above the whole square centimetre, the water, clear, cool, moving very slightly, back and forth, with a rhythm that has been running for as long as there has been an ocean and a moon. That is 1 fingernail of seafloor. And now, if you like, hold that patch in mind and repeat it. Beside it, another fingernail's width. Slightly different arrangement. Same filaments, same swaying, same fine grains. and beside that another, and another, out to the edge of the rock, and along the shore, and around the headland, and on the next coast, and the next. Every shallow rocky margin on this planet, all of it swaying gently in the same rhythm, anchored, reaching a millimetre or two upward toward a hazy sun. For hundreds of millions of years, I find this stretch of time strangely tender, because life has been single and separate for 2.5 billion years, every cell its own complete concern, dividing and drifting apart, over and over since the vents. And here, in shallow water, it begins to stay together. Not for company, there is nothing in a cell that could want company, but the effect is the same. Cells that used to part now remain. Chains form and hold. Bodies begin in the smallest possible way to exist, and they exist without going anywhere, rooted to their patch of stone, reaching upward as far as they can manage, which is not far, living entirely within the water that happens to arrive. There is no restlessness in any of it. Nothing here is dissatisfied with where it is. So let the water move against them for a while. Push and hold and draw back. 11 fine threads leaning one way and returning. The mats a little further out, rising their fraction of a millimetre. The drifting cells above, turning slowly with the current, going wherever it goes. Nothing is trying to leave. Nothing has anywhere else in mind. There is only the rock and the swaying and the cool, clear water coming in and going back under a soft and hazy sky on a quiet coast 1 billion years ago. There is one more thing to happen before we finish. It is small, just a few centimeters, and when it is done, the long quiet will be over, and everything that has ever run, or swum, or flown, or turned its head to look at something will follow from it. But not yet. There is some cold to pass through first. Somewhere around 700 million years ago, the world becomes cold, very cold, and for a very long time. The ice reaches down from the poles further than it ever has, across the middle latitudes, and in places, we think, most of the way to the equator. And it stays, not for a winter, not for 1,000 years, for tens of millions of years at a stretch. Beneath it, the seas go dark, the mats in the shallows lose their light and thin out. The filaments on the rocks lose theirs. In the places that stay open, around volcanic warmth, at the edges where ice meets water, in whatever gaps remain, life carries on at a reduced pace and waits. Though waits is my word, not theirs. Nothing down there is waiting for anything. It is simply continuing, slowly, in the dark, at whatever rate the cold allows. And then, over hundreds of thousands of years, the ice draws back. And then it returns, and then, eventually, it draws back for good. What follows is a world with slightly more oxygen in it than before, not much, but more than the boring billion ever managed. And in that slightly richer water, something begins to grow that has never grown before. Let me take you down. Not to the vents this time, not that deep. Perhaps a few 100 meters below the reach of the light, but not far below. It is dark here, genuinely dark. The sunlight gave out somewhere above us, and there is nothing down here that makes light of its own. Nothing on earth does yet. The water is cold and slow. The floor is soft sediment, and across it, from horizon to horizon, there is a living mat, the same kind of microbial film we have been with all evening, spread flat across the seabed like a carpet. And rising from that carpet, there are fronds. They stand about as tall as your forearm, some considerably taller, up to 2 meters in places. They are shaped a little like a feather or a fern frond or a quilted leaf. Rows of segments branching off a central stalk, and each of those segments branching again into smaller ones of the same shape, and those into smaller ones still. The same pattern repeating at every scale, all the way down. At the base there is a disc, a round holdfast, pressed into the mat, anchoring the whole thing to the seafloor, and they sway, very slightly, together in a current so slow you would need to watch for a long while to be sure it was there at all. This is Charnia. It was found in a quarry in England by a schoolboy, in rock that everybody had been quite certain was too old to hold fossils of anything. Here is what I find remarkable about it. It lived in water too deep for sunlight. We know that from the sediments it is found in, deep water rocks laid down well below the depth at which anything could photosynthesize, which means Charnia was not feeding on light, and it has no mouth, no gut, no opening of any kind that we can find. It has no limbs and no shell, and nothing that could be called a head. It is a quilted surface on a stalk, anchored to the seabed in darkness. The best guess is that it absorbed nutrients directly from the water across its whole surface, which is why the branching pattern matters, because that pattern is an extremely efficient way of making a great deal of surface out of very little material. But that is a guess. The honest position is that we do not know what Charnia was, not what kingdom it belonged to, not whether it was an animal or something else entirely, a lineage that tried a way of being alive and then stopped. It is one of the largest and most beautiful things ever found in ancient rock, and we cannot say what it is. Let me leave the question there and simply be down here with them for a while. The seafloor stretches away, flat and soft, covered in its living carpet. The fronds stand across it, spaced apart in their thousands. Some are the size of a hand, some are taller than you. There are other forms among them. Flattened discs lying directly on the mat, like something pressed and left there. Some the size of a coin, some the size of a dinner plate. Segmented ovals, quilted like the fronds but low and horizontal, resting on the sediment. Small ribbed shapes and rounded shapes, and one or two that have never been satisfactorily described by anybody. None of them has an eye. There is no eye anywhere in this ocean, no organ in any organism on this planet capable of perceiving a shape. So consider what that means about this place. It is entirely dark, and even if it were not, nothing here could see it. There is no perception of any kind occurring on the seafloor, no awareness of the fronds by the discs, or of the discs by the fronds, no sense of one another, no sense of the mat or the water or the dark, an enormous, silent, densely populated landscape, entirely unwitnessed, not just unwitnessed by us, unwitnessed by anything at all for the whole of its existence. Now, I need to show you one more thing, and then we can rest. Come down to the sediment, close as you can get. Down among the grains, at the surface of the mat, where the living film meets the soft floor. Somewhere around 560 million years ago, on a patch of seafloor much like this one, something moved. We do not know what it was. We have never found the body. We have only found what it left. It was small, perhaps a centimetre across, perhaps less, soft, simple, something with a front end and some means of contracting, and no hard parts anywhere in it. It was resting on the mat, feeding on it, the way everything down here fed on whatever came to it, and it exhausted the patch it was on, so it shifted, not far. A few centimetres, it contracted and extended and pulled itself across the surface of the mat to a place where there was more, and then it stopped. That is the whole of it. Behind it, in the soft mat, there is a groove, shallow, faint, a few centimeters long. It is the width of a piece of string. It ends where the animal stopped. The sediment settles over it, and then more, above that, and more, and it stays. And it is still there. We have those grooves in rock in several places in the world: Newfoundland, Australia, Russia, England. Faint, shallow lines in ancient seafloor, a few centimeters long, going nowhere in particular. They are the oldest evidence we have of any living thing on Earth deciding to be somewhere other than where it was. I opened this evening by telling you that for 3 billion years, nothing on this planet could travel anywhere. That is what ends here. Not with anything dramatic. Not with anything you would have noticed had you been floating above that patch of seafloor. A soft, small, eyeless thing in complete darkness moved a few centimeters across a microbial mat because it had finished the food where it was. And that is the beginning of everything that goes anywhere. Every migration, every set of footprints in every layer of rock, every bird crossing an ocean, every whale crossing a hemisphere, every road, every ship, every journey anyone has ever made. All of it begins with that groove. I do not want to make it sound like an arrival, because from where we have been standing all evening, it is the other thing. It is an ending. 3 billion years of a world where nothing needed to be anywhere else, where cells drifted with the water, and filaments held their patch of rock, and stone rose a fraction of a millimetre a year, and fronds stood in the dark, unwitnessed, swaying with a current too slow to see, where there was no distance to cover, nothing late, nothing pursued, nothing going anywhere at all. And then something went a few centimetres. After this, and it takes another 20 million years or so to really begin. The seafloor fills with movement, things that burrow, things that cross open ground, things that go looking. Eyes appear, and once eyes appear, everything changes at a pace this planet had never known. But that is a different evening and a different story, and it is not the one we came for. We came for the quiet part, so let us stay down here a little longer, while it is still dark, and still soft, and still almost entirely without motion. The fronds are standing, the discs are resting on the mat. The current is moving so slowly that the swaying is barely a movement at all. And somewhere out there on the seabed, a few centimeters of groove, going nowhere much, slowly disappearing under settling sediment. The last quiet thing, in the last quiet hours of a very long night. Let us come back up, away from the fronds, away from the dark seafloor, up through the cold, slow water. The cold thins. Grey comes in above you, and then blue, and then something warmer, and then the shallows, and then the shore. We started here, the warm water at your ankles, the bare stone behind you, the hazy sky. Nothing has changed. That is not quite true. And I will tell you the small ways it is not true. And then I will stop telling you things altogether. There is a little more oxygen in the air than there was. The haze has thinned. The moon has moved a small distance further out, and somewhere below the horizon, in the dark, a groove a few centimeters long is settling under sediment. That is everything. That is all the news from 3 billion years. Let the water come up around your ankles and go back and come again. It is warm. The stone under your feet is smooth where the water has worked at it and rougher a little further up. The land behind you is bare. No soil, nothing growing, just stone, running back and up into the dark. There is no wind tonight. There is no sound but the water. No birds. Nothing in the grass. Nothing at all making a sound. Only the sea arriving and drawing back and arriving. The moon is low, large and close and very slowly going. The haze has softened it at the edges. Out past the shallows, the water goes dark. And deeper still, it is dark all the way down. Fine particles are falling through it. Slowly. They have been falling for a very long time. They will still be falling in the morning. Nothing is coming. Nothing is going. There is no distance to cover. Nothing here is late. Let your breathing slow to the water as it comes and out as it goes. And again, warm water, bare stone, soft hazy sky. The tide is drawing back now. The wet stone is darker where it has been. Somewhere out there, the domes are standing in shallow water. Dark, still, rising a fraction of a millimetre this year, as they did last year. And in the deep dark, the fronds are swaying, so slowly it is barely a movement. Nothing is watching any of it. Nothing ever did. It is very quiet here. The water is warm. The moon is low. There is nowhere to be, nothing to solve. Nothing at all is moving. Only the water, coming in and going back and coming in.